So this problem, the closed rules are right the ring of the rotating merry-go-round. If the angular speed is constant, thus the closed rules have is a radius of acceleration, b is a tangential acceleration. What angle theta b should the r substance so that the a is a pole g at the point b. So this is for the rotation here. So in this case, we can calculate tangential acceleration the dv by dt or r into d omega by dt. So that we assume that the angular speed constant. So in this case, d omega by dt is 0. So the AD is r into the d omega by dt. So the r multiplied 0 is equal to 0. So this is the nose of tangential acceleration because the AD is equal to 0. AR have to be calculated. AR is omega square r. So it has a radial acceleration. So that because of this one called as a constant radial acceleration, so we use the formula omega square equal to omega 0 square plus 2 alpha into theta minus theta 0. In this case, the alpha is AD by r, omega 0 is 0, theta 0 is 0. So we write down the equation. Therefore, the omega square is equal to 2 alpha theta. But alpha is AD by r, so therefore the omega square is equal to 2 AD by r into theta. So the AR is equal to omega square r, so omega square is AR by r. So AR by r can be calculated 2 AD by r into theta. So therefore there's a 2 AD by r into theta. So in this case we write down the equation. AR is a 2 AD into theta. So A is a total acceleration, tangential and the radius are combination. So a square root of AD square plus AR square. Therefore A is equal to square root of AD square, but AR is you can substitute 2 AD by theta by square. So this is for this one you substitute the r can cancel. AR is equal to 2 AD theta. Substitute. And therefore by solving this one, what you got is the thing is 2 AD theta is equal to square root of a square minus AD square. So the divided by 2 AD, so what you got the theta equal to half into square root of a square by AD square minus 1. So in this problem, so this is the we are calculated. We calculate the angle theta. So that in this problem, A is equal to 4G. So if you substitute in the place of the A, you substitute 4G, AD is a G. So we substitute the theta D becomes 1.94 radian or 111 degrees. And the next one is the kinetic energy of the rotation. So those are the mass M1, M2, M3 are revolving at the B1, B2, B3. So in this case, the kinetic energy can be also be calculated half into M1, B1 square plus half into M2, B2 square plus half into M3, B3 square. And in this case, the rotational energy R is a so summation of mi into ri square or the half I into omega square. So the I can be calculated rotational inertia, integration of r square dn. So this is the dn distance moving the across the radius r. So that depend on the side. This is circular shape, and this is for the cloud. This is straight. This is hollow. We can calculate their rotational inertia by the law formula. Torque is this is the force. This is the AC. The force is moving around the R, so this is the torque. Torque can be calculated as 4 multiplied distance. Torque is F multiplied R or I multiplied alpha. I is a inertia, alpha is a angular acceleration. F is a 4, I is a radius. Torque equal to mr square alpha. So this problem is a mass is an M1 going down. This is density. So this is torque D. Torque D multiplied R, so this we can calculate. So the four figure show the unified this with the mass and the divided by kilogram r 20 centimeters. So the firstly we calculate T is equal to m into r. So the T minus mg is equal to ma. So the A is equal to T minus mg by m. So mr minus mg by m. So the mr is a 2.5, r is a 20 centimeters, 20 by 100. Mg is a m is 1 by 2, g is 9 by 81. Divided by 1 by 2, so you got the minus 9 by 39 meter per second square. So based on the whole linear and the angular variable, we have to study the slide 1 to 10, do the exercise the question 29 to question 30. So the next one is the torque and the equilibrium. The torque is a rotation with the this is the r, so the omega is the angular velocity, v is the linear velocity. So v can be calculated omega multiplied r. Kinetic energy K is a half into I omega square. In this case, I is a moment of inertia, omega is the angular velocity, radian per second. So those equations are this is for this circle R. Moment of inertia is I into mu r square, m is the mass. And this rate, this is a net L, so that I into half 12 by 1 by 12 ml square. And this hollow internal radii R2, external radii R1. In this case, I equal to half m R1 square plus R2 square. And this is straight. The distance A and B, so that I equal to half m A square plus B square.